Okay, if you can remember very well, this same question which I'll be tackling today was handled last week in my class. The question is, an ellipse has a major axis 120 long and its foci are 80 apart. If you can remember, I answered this question last class and I constructed the ellipse using the locus method of construction of ellipse. But today, in this class today, I'll be teaching you how to use auxiliary circle method, or you can also call it concentric circle method, to also answer the same questions. So what I'll be doing first, I'll be drawing my major axis, which is 120 millimeters long. So let me quickly do that. My major axis is 120 millimeters long. Wait. So since I've gotten my length, my A, my F1, my O, my F2, and my B, we'll be finding the minor axis. And as I said earlier, the minor axis can only be found using a compass in this situation. What I will do, I'll be taking the radius OA. I'll be taking my radius OA. So when I get my radius OA with center F1 and F2, I'll be drawing intersecting arcs above and below the major axis. Now F2 as center, intersect the arc, intersect the arc. Now if I join these 2 points of intersection together, that will be the length of my minor axis. So let's quickly do that. So from calculation, the length of my minor axis is 90. Length of my minor axis is 90. So I quickly state that down here. I'll say minor axis is equal to 90. I see that. So I've gotten the length of my minor axis. So now let's go to the construction of the ellipse. So I said in this class I'll be using the auxiliary circle method, which is quite easier and efficient, fast as well. So what I'll be doing is, with center O, I'll be drawing circles. I'll be drawing concentric circles. I'll be drawing my circles from this point C and this point D. I'll be drawing circles. From with center O. I'll draw my first circle as radius OC, and the second circle will be radius OA. So that's what I'll be doing next. So let's pick the radius. How do I pick OC or OD as your radius? And draw your circle. Then the next radius is OA. You draw another circle. Those are the circle. I think I should outline it properly for it so that you can have a good view of it. So at this point, I'll be dividing my circle into 12 equal parts. I'll be dividing my circle into 12 equal parts. How do I obtain this division? I will say 360 divided by 12. 360 divided by 12 will give me 30 degrees each. So I'll be dividing my circle using 30 degrees each. So I place my protractor center on center, straight line on straight line. So I have 30, 60, this is 90, this is 120, and this is 150, and which is the last point, 180 right there. Then I draw my lines. My radial center lines. Now those are my radial center lines. These are my radial center lines. At this point, the work is almost done, but I'll be doing something. From every point of intersection between the circle and my radial center lines, anyone that intersected on the major circle, I'll be drawing lines projecting downward and upward. That means from this part the lines will be coming downward, and from this lower part the lines will be going upward. Then from any part the radial center lines intersect the minor circle, it will be going to the left, and to the right. So let's redo that. I'll be using even points to draw it. So here it is. So from here I'll be going up, coming down, joining these 2 points as next. I'll go up and I'll come down, using these 2 points as the next. I'll go up and I'll come down, using these 2 points as the next. I go up and I'll come down. You can see that. Now we're going to be drawing for the minor circle. So for the minor circle, I'll be going to the left and to the right. I'll be going to the left and to the right. So intersected at this point. So I'll be going this way, this way. These are the next point of intersection. This way and this way. These are the next point of intersection. So going this way and this way. And this is the last point of intersection, going this way and this way. So after arriving at this, what I will do quickly is I'll be drawing arcs. Or should I use it a curve? I'm producing my curve that will join it to create the ellipse. So let's quickly draw the arc. So what I'll be doing with my French curve, I'll make sure I'll join every three points if possible. Now, where am I joining? I'm joining this point of intersections. This point A, this point of intersection, passing through C to this point, to B, then to this point, then to D, and this point, and this point. So I'll be joining those points of intersection. I'll be picking it 3 at a time. Then I'll be picking the next tree. Take note of this. The next tree will start from this, which is 1, 2, 3. That'll be my next tree. But if I pick that, let me create the curve from this point. Then now I join these 3 points, this 1, 2, 3, with a curve still. Let me introduce another French curve to see if it's give me what I'm looking for. I think this one isn't giving me what I'm looking for, so I'll go back to the first one. Okay, I think that my French person are not giving me that, so I'll be taking these 2 points first. I'm taking that 2 points first. Then this next. Oh, finally I got that part of it. So the next point is the lower part of it. Can see that? Now I take this point next. Remember, I'm taking 3 points each with my French curve. Then now remember this. So I'll pick 2 points here. I'll pick it to 2 points instead, since the 3 points refuse to enter. Then the last point. So this is the ellipse, and I'm done with the construction of the ellipse. Now, but the question is not done at that point. The question went ahead to say, so the next thing to do in this question is, it says, draw a tangent and normal to the curve at a point P, above the major axis. That means the point P will be above the major axis. That means this region to be above it, and 35 to the right of the minor axis. And to come to the minor axis, to the right hand side, 35 at the right hand side. So that's the question. So how do I obtain that? I'll take my ruler. It says it is above the major axis, right? So what are we doing? I'll be going from O, going up towards C. I'll be going 35 towards C. Since it's above the major axis, I'll be going 35 towards C. So I have 35 at C. At that point, I'll be drawing a perpendicular. I'll be drawing perpendicular to be coming to the right part of the minor axis. So anywhere that perpendicular caused by minor axis is the point P. And I believe a perpendicular is a straight line of 90 degrees. Okay, so I have it here. So this point is P. That point is P. I found my P. So we found the P. What we have to do next is to draw the tangent. After drawing the tangent, we can use the tangent to determine our normal. I hope you know that a tangent is perpendicular to a normal. Likewise, a normal perpendicular to a tangent. So to get that, I'll be drawing a straight line. I'll be joining F1P and F2P with a straight line. Then I can also extend my lines. I'll be joining F1P with a straight line. I'm extending the line. As well, F2P with a straight line. Then I'll extend it. After arriving at that point, pick your compass with center P and a covenant radius. Draw an arc in this manner. Make sure the arc is cutting the line coming from F1 and the line coming from F2. Anyway, you cut the line from F1, name it P1. And anyway, you cut the line coming from F2, name it P2. Now with radius P1, P2, with radius P1, P2, and P1 as center. P1 as center, radius P1, P2. You draw an arc up there. Sorry about that. Radius P1, P2. Radius P1, I draw the arc up here. Then now with P2 as the center, with that same radius, I intersect the arc. Now at that point of intersection, I will draw a straight line from that point of intersection crossing through P. I will draw a straight line from that point of intersection crossing through P. That straight line is called the tangent. That straight line is called the tangent. That's the tangent. That's the tangent. This is the ellipse. So I'll be drawing a normal at this point. A normal is perpendicular to the tangent. So that means it's a straight line at 90 degrees to the tangent. And my normal will be coming from the point P. So how do I achieve that? With P as center, and the same radius I use in drawing for P1, P2, with that same radius, I extend my arc to make sure it cuts my tangent on the other side. You can see that the arc is cutting the tangent on this side and also on this part. So on those 2 points of intersection of the tangent, I will label it T1, T2. So with center T1 and T2 respectively, and the radius is T1, T2. Radius is T1, T2, but the centers are T1 and T2 respectively. So I'll be drawing arcs, intersecting arcs from those 2 points. Then pick the radius. So I will draw my arc going up, then intersect the arc. Now I'll draw a straight line from that point, from the point P through the point of intersection. That straight line is called the normal. That straight line is called normal. So we are done answering this particular question. This is it. That is the construction of an ellipse using auxiliary circle method. I use auxiliary circle. Last week I taught how to use locus method to construct ellipse, as well as drawing your tangent and normal, and as well as finding the length of the minor axis. But today I taught you how to find the length of the minor axis using auxiliary circle method, as well as how to construct the ellipse using the auxiliary circle method, constructing the tangent and normal to it. So don't forget to ask any question you feel. If you're not clear about the video, you can ask your comment, drop your comments in the comment section. When I come online, I will still attend to you. And if you have any construction you would like to learn, you can still drop it there. Please don't forget to subscribe and like my videos. Thank you so much.